there, this is Meowy. I'm a software engineer and also a Rust engineer. So in this series, what we're gonna do is we're gonna go from complete beginner to Rust intermediate and advanced. So I don't expect you to know like any Rust. So I am gonna take you from like very beginning to later stage. So this is a journey that we're gonna go together. I'm super excited for this. So let's go. Rust is currently considered the most important and also the future of programming. So why Rust is the future? Well, three reasons. First, the memory safety. Rust catches a whole lot of bugs during compile time. And the second part is the fearless concurrency. You can write multi-threaded code and the compiler proves it's free of data traces before it runs. And finally, the third, real performance. It's as fast as C++, but no garbage collector, pauses or surprises. Let's get started and set up Rust in your own machine. Installing Rust takes only one command. You can just open your terminal and paste this and hit enter, and the script downloads and set up Rust up and the official Rust installer. Once it's done, you can just run Rust C and version to confirm if it's working, and that's it. Cargo is Rust build tool and package manager. It does most of the work for you. Well, there are two commands to start a fresh or new project. At first, you can run cargo new my app and it creates a fresh folder with a project inside of it. And cargo init inside the existing folder does the same thing, but it's inside an existing folder. So you can drop in Rust into an existing directory. Same file comes out either way, it's just a different types of starting point that you can use. So what's inside your cargo project? Well, it starts with your cargo.toml. That's why your project metadata lives. And then there's cargo log. This is where you just pin down the version and it's completely auto-generated. And then the main.rs, this is the entry point. That's why you write your code, all of them. And then there's target. This is like compiled binary and always git ignored. And lastly, there's git ignored. This just it should leave alone and cargo sits with it with the target. So that's only it. Let's go ahead and write your first ever program in Rust. Run cargo new hello and open the main.rs. And you will see the classic hello world. Run cargo run from the terminal and cargo compiles your code and runs it hello world within 30 seconds. Let's break this down piece by piece. Fn is the function keyword and every function in Rust starts right over here. And then the next is the main, which is a special name. When you run a Rust program, execution starts right over here. Every binary needs exactly one main. And the empty parenthesis means main makes no arguments right now. After that, the curly braces are the function body. Everything inside runs when the function is actually called. And after that, there is the print line macro. And macro expand at a compile time. The exclamation mark is how Rust tells you something is a macro, not a regular function. And then the text in the double quotes is a string literal. That's what gets printed when you run the program. Variables and mutability. In Rust, you use let to bind a value to a name. Let x equals to 5 and Rust figures out the type from the value, and in this case it's i32, the default integer. And if you want to be more specific, you can annotate the type yourself by let y colon i32 and this figures out. And there's also the strings which works the same way. It's just like name equals to quote, which we use to make sure that it's string inside of the quotes. There are also string literals and a few other things. We'll get into those later. There's constants that are different. You use const keyword, the type is required, and it's screaming camel case. Constants are evaluated at compile time, not runtime. And then if you try to reassign a regular let to a compile, and the compiler will stop you. Variables are immutable by default. We'll fix that in a second. Shadowing is a Rust quirk which you can use and reassigning the same value, and it creates a brand new binding. You can even shadow inside a block inside the curly braces. X is a new variable, and once the block ends, the outer X is back untouched. Variables are immutable by default in Rust. Try to reassign one and the compiler refuses. That's not a bug, it's a guarantee. If you do not want to change a value, opt in with a mutable keyword like with mute. Now you can reassign as many times as you want, as long as the type stays the same. But here's the thing, mute and shadowing aren't kinda same. Mute keeps the same type and you can just change the value, but not what the value is. Try to reassign a number to a variable that started as a string. It won't really compile. But shadowing is also more powerful. It uses the same name, brand new binding, and a fresh type. You can take a string slice and rebind it to its length with no problem. You need a different type, use let. You need a new value, same type, you can use the mute keyword. Now let's learn about the data types. Scalar types hold a single value. It's like there are 5 flavors or something. First, the integers. I32 is the default. But I32 signed is the most fastest for the CPU, but there are also other types. There are also unsigned integers like U64 are 0 to positive only. Great for sizes, counts, and indexes. Floats F64 is the default, 64-bit, double the precisions. Booleans are true or false, 1 byte, no truth in Rust. Be explicit. Chars are single Unicode scalar values, 4 bytes, use single quotes, and even emojis work on this. And then I just want to mention that integers come in 6 sizes. Signed, unsigned, pick the one that fits your value range. If you're not sure, use I32, and there are like 5 ways to write a number: literal, decimal, hex, octal, binary, and a single byte literal for U8. So you can pick your own data type and work through it by being explicit about it. Compound types are a group of multiple values into one. It's like multiple values or flavors in together. First, let's look into the tuples. It's like fixed length and the max type group. And this mixed type is there's like types inside the parentheses with each item's type. To get the value back, you can deconstruct it with like you use let, and inside the parentheses you put x and y and the name of the tuple. And you can also have the direct access with .0 or like .1. And then there's arrays. So arrays are different. It's like same type but fixed length. And the type is like inside the third bracket, and you just mention what is the type of the array. In this case, it's I32, and there would be like 5 I32 values inside these arrays. And also you can sometimes you can create a shortcut, like if it's the same value for 10 times, you can write it like this: let zeros, and inside you mention this like 0, and it's like 10 times. Well, that's one of the way. And you can also like go in, like you could go into array index to get the value of what it is, and you mention the index by over here, like let item num0. But over here, if the 0 is out of bound, you get an error. Tuples and arrays are both fixed at a compile time. If you need to grow it, you want a vector, and we'll cover that in the later videos. A struct is your custom shape for related data. You can define a struct with struct keyword and a name in a Pascal case. Inside the curly braces, you list each of this field as a name with colon type and comma at the end. This is actually important. So this is a struct, and this person has to have a name, an age, and a cat field. Well, cat field is boolean. Just want to know if this person is a cat person and has a cat or not. And each of one of these has a fixed type. If you want to make an instance from this struct, you need to type the name in curly braces and fill every field. But field name has to match the definition. The order doesn't really have to. Notice the name field uses a string double colon from. So what we are doing is we are converting a string slice into a owned string, because that's what the field expects. Once you have an instance, you can access a field with a dot and the name of the struct. So it's like Meowy.name, Meowy.cat, something like that. The struct lets you bundle related data into your own custom types. There's a lot more you can do with them, like methods, tuple structs, enums, but that's chapter 5 materials, not right now. Now we're gonna learn about functions and the control flow. We have already seen the fn main, like fn declares a function and main is mostly the entry point. And there's curly braces for the body and snake case in terms of names by conversion. Now let's add a parameter. Well, function greet has this parameter that we are calling by $str, which takes one argument, which is a string slice, and parameters always need an explicit type. Rust never infers them. Well, if you need multiple parameters, well, you can just separate it by using comma, and each gets its own type. Now let's take a look at the return values with the arrow syntax. Over here, this function takes an integer and returns as an integer. And the last expression in the body, over here, if you notice, there is no semicolon. This is a return value. So x plus 1, no semicolon, returns this x plus 1. And there's this fun moment, is if you add a semicolon, you turn this into an expression, into a statement, and statement returns unit, the empty tuple, and the function won't compile. So calling them is what you expect. So this is why greet code, this is just calling, and capture the return with the let, and let n equals plus 1, 5, and n is 6. Well, these are just commands, and you can just use it with double slash types. And there is also multiple line comments that you can use. This is quite simple. Also add comments at the end of the line. If else kind of gives you a fork on the road. It's like basic shape. If condition, run this block, else run that one. Both block live within these curly braces. There's no parentheses around the condition. Unlike C or Java or JavaScript, Rust doesn't really want them. The condition has to be a boolean, not an int, not a string, not a maybe thing. Rust won't auto-convert. If you want to check a non-zero, you can just write n is greater than 0. But there's this thing, it has to be a boolean. There's also a Rust feature you won't find in most language, is that if it is an expression, it can return a value. The result of if becomes a label, and both arms has to have returned the same type. For more than two cases, you can chain this else if within this if else, and you can check from top to bottom and stop at the first true value. If the chain gets too long, you can always reach for the match type instead. But we'll cover match in a later video, not right now. There are three types of loops in Rust. At first, a loop that just runs forever until you just call a break. So you can decide when it stops. And here's a Rust quirk. Break can return a value also. Then there's this while loop, which becomes an expression you can bind. So you can just like run let result, and you can equal this loop to within these curly braces, and you can just break it by like reaching a certain counter, and the result is whatever the break gives back. But in case of a while loop, it checks a condition before each iteration exits when it becomes false. Now for loop works a collection or a range. The most common loop is the for loop that mostly we all gonna write. It's the safest, no off by one bug, and it's usually the fastest since the compiler can skip bounds check it knows are unnecessary, right? And when it does, just reach for loop, no need to think too hard. And for nested loop, you can label them with the code and the name, and it just works. Then break, or you can continue and target the loop if you want, instead of just the innermost one. So that's it. You need to keep in mind that the compiler is your friend. It catches the bug before they ever run. That's the Rust difference. That's a wrap. Now you know enough Rust to write a real program. Up next, we're gonna tackle ownership and the borrow checker, the features that makes Rust special. If you want to follow along, you can follow along with this journey, and I'll see you in the next one.